I have to create a mapping service so that my interceptor calls a mapping service, and I make sure that I'm extracting the necessary data, a human in the loop process, into all of your use of AI data. And this to me is really the foundational requirement. You have to do that anyway. You have to it's a bottom-up, top-down process. So in order to implement FHIR correctly, safely, and effectively.
Welcome to a brand new episode of the Why Involved podcast. Today's guest is someone as fascinating as the world of AI tech itself. Eric Uwe, CTO of 22 Paths. Eric has been at the forefront of healthcare technology innovation, from crisis management platforms to secure Azure architectures, and using AI for real-time patient care. He has done it all. He has held transformative roles across several organizations. And today, he brings insights that are both inspiring and eye-opening. At 22 Paths, Eric's leadership is shaping the future of healthcare platforms that are secure, scalable, and future-ready. One of the core technologies in that journey, the ABP Framework. To kick things off, Eric, when it comes to implementing complex frameworks like ABP in the healthcare industry, there are a lot of moving pieces. The challenge is balancing flexibility with structure. So, Eric, from your experience, what would you say about the key consideration when implementing ABP frameworks for healthcare solutions?
ABP is very opinionated, which is wonderful on the one hand, but also because of how highly opinionated it is, very often when working with healthcare data and healthcare applications, you discover that a fair amount of customization is required as well. So in the work that I'm currently doing, right now I'm a team of one. So I am actually using ABP to create a pilot. So ABP is allowing me to create a pilot using a tiered monolith. So it's very, very fast for me. Okay. So, and what ABP is doing for me is it's taking care of the sort of foundational requirements so that I don't have to think of them. So out of the box, I have good identity support, good auditing. It's very easy for me to spin up clients. And of course, ABP being built on top of .NET, I have even the more lower level foundational .NET stuff that I can use. For example, in a FHIR client, so I'm talking to a FHIR server, it's fairly trivial to write an interceptor for that so that I can log and audit requests that are not going through HTTP context directly. So, the client is kind of abstracting away a lot of that for me. But between ABP and .NET, I am still able to spin up the kind of middleware things that I need. So ABP is really outstanding when it comes to giving you a set of features out of the box that accelerate your development greatly. Now, the flip side of that is that you do have to take really good care as early in the game as possible. So in healthcare data, auditing out of the box, like ABP style auditing, is wonderful, right? You get the standard data from a particular audit entry. But what I've discovered is that pretty early on, you have to pay attention to creating an audit map. So HIPAA, FHIR, GDPR, I have particular requirements for auditing data that are largely supported by ABP out of the box, but not entirely, right? So early on, I have to create a mapping service so that my interceptor calls a mapping service and I make sure that I'm extracting the necessary data from all of my FHIR requests, so that I can customize the audit log and inject the necessary data into that. Um, and it so sort of from top to bottom, what it has allowed me to do is it has allowed me to pay attention to sort of domain specific concerns, right? So I need to connect to health information networks. I need to figure out how to curate FHIR data so that I am producing a highly customized screen of data for an EMT or an emergency room doctor. Uh, ABP allows me to focus more on that and less on the sort of platform specific requirements that I would ordinarily have a team building for me for some period of time, some months or whatever.
That was really insightful because I can see a lot of customization is being done for healthcare specific, which is awesome. At 22 parts, ABP is an integral part of your tech stack. It is known for streamlining processes and improving overall system performance. Can you share how the ABP framework has supported your projects, particularly in terms of scalability, maintainability, and faster delivery?
Sure. I'll take them in order. Scalability. You have a lot of options when you want to deploy an ABP application or platform. Right now, as a team of one, I'm using a tiered monolith. But even the tiered monolith, right? I wouldn't want to say that it's exactly like Conway's Law, because as a team of one, there's no communication structure. It's just me right now in the work that I'm doing. But it's kind of like that, right? As a single person creating this application, a tiered monolith kind of fits that mental model of one person working away on something. That said, I'm also making extensive use of ABP modules. So wherever I see, so I'm kind of approaching it as a design, domain-driven design exercise, right? So wherever I think there's an aggregate root, I can create a module for that. And that does a couple of things. It turns that tiered monolith into a better organized tiered monolith that is easier for me to develop alone, but is still very simple for me to deploy using basic models like an Azure app service or an Azure container app, right? So it's sort of an easy path to somebody who's pretty quickly trying to spin up something and get a pilot out the door. That said, there's also an easy path to a microservices architecture, because the DDD modules that I'm creating in my tiered monolith, I can repurpose them. I can either include them wholesale in a microservices module, or I can just extract the entities in the application logic from each one of those and put them into a module. And when I do that, my scaling options sort of increase exponentially, because now, of course, the microservices bonus is that you are clearly defining all of your aggregate roots and you're isolating that. So you have, as many aggregate roots processing power, right? So I can stand up different containers for each one of those and scale them independently. So ABP really does a fantastic job of letting me work at all due speed as a single person creating this, but to avoid sort of horrific technical debt of getting stuck inside of a more traditional monolith, where it would be a very large effort to sort of decompose that into services. So the scaling story for that is really outstanding, and ABP um, with its the ABP CLI makes it very trivial, and now ABP Studio, they make it very trivial to spin up applications using these different templates, right? So I spend very little time working on boilerplate stuff, spinning up new applications and having to configure them from the ground up. A lot of that stuff is taken care of for me by the framework itself. Uh, Second one was speed, yeah? Yeah. So speed again. So with ABP, you have to pay a certain amount of attention to ensuring that you don't overload the solution with optional modules. Um, I don't have hard evidence that, including file management and chat and some of the other, optional modules degrades performance. But when you have a sort of clear mission and mandate to produce a particular kind of application, in this particular case, healthcare, um, some amount of care is required to make sure that the application starts out life as lean as possible. Um, and from there, if I exercise a bit of care um, in the initialization part of the project, it becomes easier for me to optimize particular modules, right? So the first part of the question, the modularity of ABP also helps very much with optimizing for speed. So scaling and speed go hand in hand here. And again, it's the wealth of options I have to deploy this platform, right? Um, so again, for the moment, it's a tiered monolith, but when I grow a team around it, and also for the purposes of teaming, even the tiered monolith is not a bad way to go, because I can construct teams of teams around individual modules, so that I'm kind of paving the way for the microservices implementation of it, where those divisions become a little more enforced, right? So I'm definitely going to have teams that have responsibility for a particular module or some small number of modules, and they are no longer constrained by worrying about the architecture and the rest of the application, as long as I have architected the solution correctly and really analyze the domain correctly. Okay, so part of scaling in speed in ABPIO is taking advantage of the underlying DDD approach to creating the platform, and being very clear that I understand what the aggregate roots are in my solution, and what things need to be dependent entities and what things can actually be value objects. So like very, very lightweight and very carefully controlled by the aggregate root, right? So that is sort of a conceptual exercise that feeds my ability to scale this and make it go fast.
Right. That's a great example of impact of underlying architecture that you have. And very insightful. I think you have crafted it very thoughtfully. That brings me to the next question. When we talk about scalable and AI-driven healthcare solutions, there are several challenges that arise. What do you think is the biggest bottleneck in building these type of solutions today?
Yeah, well, there are a couple, and the first is obvious. The first is data. So data is always the bottleneck. Healthcare data is highly regulated. It is expensive, or you have to form great partnerships early in the process, so that you are working with we've reached out to regional health information networks to cut deals with them so that we can use their data. So we'd be like any other consumer of this health information network. Um, but that said, given the general expense and highly regulated nature of healthcare data, that is the first bottleneck. So just getting access to it, right? Once you get the access to the data, the governance requirements for it inside your platform and sort of around your platform, right? Uh, they're very steep. So you have to make sure that you're not running afoul um, of some of the harder requirements of data security in a healthcare application. Um, the second uh, sort of bottleneck there is AI itself. So AI is still relatively new. It has a kind of, I'll call it a kind of tortured relationship to data, right? So think about foundational large language models that are out there today. They became what they were essentially by scraping gigantic amounts of public data, right? And the sort of retail use of these large language models, um, the the ownership of the data is somewhat fuzzy. It just in terms of intellectual property, it's all sort of a gray area. So what does that leave you? It leaves you with the requirement that you have your own walled garden. So I tend to use Azure a lot. So, Azure AI Studio, for example. And so what I need to do is I need to stand up my own vector database, my own data store. I need to point it to my own production database for certain tables worth of data. Um, then the second part of that is somewhat of a bottleneck is ensuring that the the tuned models that I produce are accurate, and also doing a very careful analysis up front to determine whether I should be using AI for this particular purpose at all. It requires a fair amount of analysis to sort of strike the perfect balance between gee whiz, isn't this extraordinary kind of features that can be very attractive to customers, and the expense of doing it and the liability of doing it. Because in particular with medical data, um, there's a lot at risk in false positive, false negatives. You can't have your model hallucinating incorrect data. So the third part of that, third sort of bottleneck there is that when you want to use AI for healthcare data, you have to build a human in the loop process into all of your use of AI data. Okay. And this to me is really the foundational requirement for using AI in healthcare. I've been working with, we're at the very early stages of sort of feeling each other out, but I've been working with a company called Cordy AI, and they have taught me a lot. Their platform is really exemplary of the kinds of care that are required when using AI for healthcare data. So they all of their models are walled off. They have large volumes of verified medical data. They have large amounts of training data from EHRs. And their processes have been very carefully constructed to use human in the loop intervention at all critical points, right? So one of their flagship features is ambient note taking. So I come to you for a consult about something. You and I talk, and in the background, the LLM is recording us and taking notes, right? The second part of that process, and this is again, where bottlenecks arise. It's not a simple, straightforward process of having an ambient note taker take notes and then spitting that back to you in the form of a transcript. The work comes when you realize that the first thing that has to happen with that set of ambient notes is that something has to extract the salient facts from those ambient notes and organize them. Then it has to take that collection of facts and come up with some supposition about what the general context of the conversation was and what direction the practitioner might want to take. Subsequent to that, here's where the human in the loop process begins, because now trained medical personnel have to review this. Okay, that's just for a little bit of a long-winded example, but it's really emblematic of the amount of work that AI takes to implement correctly in this domain. It's a very large bottleneck in and of itself, with fantastic potential to change how practitioners and patients interact with each other, and to change the nature of the services that we can offer to our customers, right? So that rather than being just a kind of static recitation of historical fact, we can help our customers dynamically organize their care plans, for example, track their status, ping them with motivational notes, with follow-up notes, reconnect patients with practitioners in a very dynamic and thoughtful way that it is impossible to do using just a rule-based system or a data-based system.
Yep. This is very fantastic use of AI in the real world scenario. So I'm really delighted to see how the AI has been leveraged here. Healthcare interoperability remains a significant hurdle in modernizing systems. Given your experience at 22 Paths, now how do you approach implementing industry standards like FHIR, CCDA to improve data exchange and system integration? We are eager to hear your strategy.
Sure. So again, I made my choice, and I've been working with Azure for a while now. I'm not going to say that they're completely interchangeable, but the major cloud providers all offer roughly equivalent features. So, what I'm saying about Azure, I know with some confidence applies to Google Cloud, for example, right? Or AWS. So for me, the foundational choice is to use Azure healthcare services. And what that allows me to do, for example, is to spin up a FHIR server. Now, this FHIR server is HIPAA compliant. It has been vetted, so it has the required physical safety constraints put on it, data constraints that are put on it. So as you go up from physical to sort of more abstract, Azure has done a lot of the heavy lifting. And again, all cloud providers will do roughly the same for you, right? So the FHIR server itself is sort of the linchpin for me, because it allows me to spin this up, import large amounts of data, and it gives me a place to store certain things like value sets. So let me step back for a minute. When you want to implement something like FHIR, there's a sort of lower level stuff. Can I talk to the server? How do I do that, right? What kind of authentication do they use? Okay, that's easy stuff, right? All right. If you step back and put on your business hat and you say, okay, what is it that we're trying to do here, right? So some of the work I'm doing now is around something called care plan harmonization, right? Let's say, for the sake of this example, that I have multiple chronic illnesses. I am a very complicated patient. I see many, many specialists, and I have perhaps drug regimens with each, treatment plans with each. How do I unify that? Right. So now I'll put back on my sort of platform hat. How do I create a platform that helps patients unify that? Okay. Um, so that they know everything there is to know about their own treatment. And trust me, as uh, this is part of my lived experience. Um, Care plan harmonization in the States, for medicine in the States, is very, very tricky. It's very, very elusive. A lot of specialists, a lot of siloed data, you know, fantastic, talented people working in a tough system. So now, if you step back up and you look at the problem through a sort of business lens, you come up with the concept, this sort of conceptual framework for what it is you need this implementation to do. And then you go back down. So you start with implementation guides. Okay. So if I want to implement a FHIR server, really the most important thing for me to be able to do is to consume and manage implementation guides, because an implementation guide in FHIR says, okay, here are your profiles, right? So here are your invariants. These are the rules that you have to follow to use this stuff. Do you want to create extensions for this? How are you going to manage references between different resources? So you go back down through implementation guides, through profiles and references, and you sort of come out the other end with a much more enlightened view of what you want your FHIR server to do. Okay. All right. So I've said all of that, and now I'm going to give you a kind of real world counterfactual. Very often, when connecting with health information networks, they will give you access to patient/$all, or excuse me, everything. So you will get this enormous bundle of stuff. Okay. And the IG that they're using and the profiles they're using may not completely coincide with your sort of idealized IG and set of profiles. That said, you're not off the hook. You have to do that anyway. You have to, it's a bottom-up, top-down process. So in order to implement FHIR correctly, safely, and effectively, you do have to get the sort of bottom-up stuff. How am I managing clients? Because many, many people are going to be hitting the FHIR server. What sort of caching scheme am I using to sort of minimize, right, the load on the server? And how am I splitting the difference between cached data, which will be eventually consistent, and the requirement that anybody looking at the system at any particular moment is getting current and correct data, right? So the lower level stuff, and again, the higher level stuff coming down, do I fully understand the requirements of my business? And do I understand what that actually means in terms of implementation guides? So the bottom up and the top down shape in every project. They shape the necessary approach to satisfying the business requirements.
Yep. So that was, there are too many parameters for your strategy to cover, but that is very insightful. Designing a crisis management platform is no small feat, especially when ensuring HIPAA compliance and maintaining high levels of data security from a technical perspective. What are the critical factors to consider in building a platform like this? It would be great to understand your approach in detail.
Sure. Typically, I will use, I use um, Azure Cosmos Postgres. Um, it is relatively cheap compared to standalone SQL Server, for example. So for relational data, I will opt for that. One of the benefits I get by choosing that is that it's FIPS 140 compliant. So it uses AES 256 encryption for data at rest. So that right there, that's a good chunk, right? It's sort of necessary, but not entirely sufficient. Okay. So that's sort of level one. Level two is that it requires careful design to understand where in the PHI I need to encrypt individual columns. So the FIPS 140 stuff is awesome, right? I kind of get that for free. So at rest, it's very good. But there's still data that really needs to be encrypted before it goes in there, right? So in Azure, it's a system managed key, which means that in principle, it's very difficult to get to. Nevertheless, it is not adequately secure for all healthcare data. That's where the second part comes in. So it sort of devolves to me to look at the data and say, let's pick some obvious cases, right? Social security numbers, some other, depending on how we're uh, either trying to obfuscate data or the data that we feel needs to be protected. Then I get to go in and I get to use some of the niftier features, say, of Entity Framework, or and when you use the Postgres driver, where I can use value converters so that I can encrypt that stuff using some service that I write using known encryption packages to encrypt that stuff before it gets there. I alone, or we alone, own that key, and if we're smart, we have it off in Key Vault, and we rotate these periodically, and we do whatever we need to do, whatever sort of strategies are required to keep that safe in the long term. So at a fundamental level, the data story it's fairly low level, but it is founded on encryption early and often with a really enlightened view of what in your data needs to be encrypted. Okay. Some of the complexity there is that, say, for example, I might be interested in querying on social security numbers. I don't know why, but let's just say for the sake of argument, I want to do that. So one of the additional requirements then is that I use good hashing, so that in addition to storing that encrypted social security data, I store a hash of it. So I can index that hash, and then I can use it for querying. Okay, so that's the sort of foundational requirement for implementing sort of, security first, or, security left sort of practices. Beyond that, the platform itself really needs to provide robust role-based access control. Good identity it needs to have a very robust identity module, right? So starting from the beginning, let me just back up for a second and give you a little story. I don't know if we're going to be able to work with them because they seem to be shifting their focus away from smaller outfits like us, but I have done a lot of work with ID.me. Now, ID.me as an identity platform, one of the benefits they gave us was the ability to know that somebody who logged in had this professional credential, right? Or that this patient was in fact this patient. So we knew with a high degree of certainty using ID.me that the people who were logging into our system were in fact the people that they purported to be. And if you think about it, the the basic model of authentication on the web, it's sort of like it's almost like kids cheating on a test. And honesty in testing assumes that the kids don't want to share their answers. If they do, right? Or like passwords to bring it a little closer to home. Um, Passwords are great unless somebody really wants to share it. Share their password with someone else, right? Look at the difficulty that Netflix has had. They had to spin up an entire layer in their platform to deal with people who wanted to share their credentials. Okay, so for us, a service like ID.me was really marvelous because it gave us the confidence to know that the people who were logging into the system did in fact have the identities they claimed to have. All right, so if we're not going to be able to work with them, we will have to come up with alternatives. We'll either find another provider or we will go directly to the NPI registry. So the government maintains an NPI registry of all licensed providers in the country, right? So we would have to require people registering with us to provide us their NPI number, and then there'd be a validation process during onboarding. Okay, so we have data, we have identity. On top of that, I got a little bit ahead of myself. We have role-based access control. And here too, ABP gives me that out of the box, and it's highly customizable. I can extend it, I can customize it. On top of that, again, because it's .NET, I can use, for example, a package like Casbin.net to apply attribute-based access control policies, so that if I want to get really, really granular about it, not only can I derive a piece of required information from the fact that this authenticated user occupies this role in the system, but now I can inspect the records that the person is looking at for critical pieces of data, right? So it's identity, it's attributes of the record, it's the environment that somebody is accessing the record in. I can control for all of that as well. So starting from that sort of, and this is, even though this has been somewhat of a long answer, this is also a very short answer because it's a complicated, it's complicated business to secure all of this stuff correctly, right? But if you look at it as a whole, it starts with securing the data and being enlightened about what needs to be encrypted before it's written. And then the identity layer, giving you the best shot at being highly confident that the people who are using the system are the people they claim to be. And then on top of that, your ability to selectively grant and deny access, selectively grant or deny authorization to view particular resources in the system. So those three layers are sort of the basic hard requirements of being able to get something out the door. Of course, when it goes into production, you need a full-on DevSecOps team to monitor everything. You need intrusion detection. You need to have outside auditors come in and do periodic deep dives into your security posture. But those are the basic elements.
Absolutely. And that brings me to the next question. As you know, generative AI is started to make waves in patient engagement and in these and there is immense potential to transform sentiment analysis in healthcare. How do you see generative AI shaping patient engagement and sentiment analysis in near future?
It's a sea change. It's going to be a brave new world. And I touched on some of this before. it's going to require a lot of planning up front and a lot of thoughtful design so that there's always a human in the loop. And I'm not sure that this is ever going to change with medical data, right? We're always going to need highly skilled, trained, experienced people to be able to pop back in to the system and vet the quality and accuracy of the data that people are seeing. But for the consumer, um, it promises the ability to begin to create what I've called intentional UI. So that rather than having a kind of static form-based UI where I will go in there and I will click on links and I will type in certain pieces of data and get back certain pieces of data in forms or tables or whatever, I can engage with my own data in an intentional fashion. That is, I express my intent to the system, and it can answer me in a conversational way that is fast, adaptive, and extremely engaging because it's like I'm talking to you rather than reading data in a form, right? So there's promise for both practitioners and patients for these newer kinds of user interfaces that are predicated on really solid large language models that can detect sentiment and extract facts and compose long form thoughtful answers, or to take a completely different tack on it. So take the same piece or same set of medical data and make it accessible to a practitioner on the one hand, but equally accessible to a patient on the other without distortion, right? Or without losing fidelity. Me, as a layperson, I have no particular understanding of medicine. I have a sort of average layperson's understanding, medical terminology and disease processes. But very often it's the case that patients today, they look at their case notes and their eyes sort of glaze over because it's the practitioner has to write it for correctness and completeness because it goes into the permanent record, right? That is not amenable to my understanding, right? Because I'm just a layperson. It's sort of above my head. It's beyond me. Large language models, AI, generative AI, they have the promise of making that data as accessible to me as it is to my provider. And that will be a really remarkable event when that becomes more widely used, right? So part of what we're doing at 22 Paths right now is getting all of the pieces together to make sure that our system is robust, that we're working with the data correctly. And essentially what we're really doing is we're positioning ourselves to take the best advantage of this emerging technology, and to go all the way back to the beginning. I think one of the things I mentioned is that very often it requires you to make good partnership choices, right? So a lot of the work that we're doing is to vet partners, to make sure that there's no impedance mismatch, right? We're this big, they're that big. How long have they been in business? What's their revenue model? What do they expect from us? What can we expect from them? In terms of services, the stability of services, the cost of services. But if we can do that and we can partner with the right people and then spin up our own for the remainder, very quick example. For example, I would love for our platform to have the ability to use some sort of agentic AI to give people notifications about various things happening in the platform. That's separate and distinct from the more properly medical use of AI. So I can go and do that. I can work with partners who have the data and the infrastructure and who have done all of the very difficult work of training their models to work with medical data. And we can partner together to insert that into our platform to our mutual advantage and to the advantage of practitioners and patients. The future is very bright for healthcare technology. It is still a very complicated landscape with a lot of siloed data and processes. And some of the, it's a little bit interesting that some of the largest players, like Epic, are kind of constrained by their size and by the ubiquity of their platforms to perhaps innovate more slowly than some smaller startups like us can innovate. So the sort of confluence of well-intentioned, dedicated practitioners, state agencies looking for new efficiencies and ways to save money and to extend the reach of their services, smaller startups that are, as we like to say, scrappy. We are willing to work with anyone if it's to our mutual advantage, and we are willing to pivot. We are willing to learn and to discard stuff that we've done if we deem that it's no longer effective or appropriate. This confluence of events is a sort of watershed moment for the evolution of healthcare technology. And the next few years are going to be very, very exciting for practitioners and patients. And I hope will really allow public agencies and governments, like I just said a moment ago, to extend the reach of their services in difficult financial times or interesting climates, right? So I think we are at this sort of inflection point where we have a great opportunity to change the way stuff is done, and I'm thrilled to be a part of it.
Absolutely. It was a pleasure to host you, Eric, today. And I'm pretty sure we'll get many more chances to connect with you and invite you on our podcast. So thank you. Big thank you from all of us here. Thanks for being part of Why Involve Network.
Thanks so much. It was my pleasure. I enjoyed it very much.
That brings us to the end of this insightful conversation with Eric Ove. We hope you enjoyed diving deep into the intersection of AI, scalable architecture, and healthcare innovation. If you have an interesting topic to share in the AI space, write to us. We just might pick it for our next episode. Don't forget to follow us for more expert-led conversation that help you stay ahead of the AI curve. Join our LinkedIn community on LinkedIn. Until next time, stay curious, stay inspired, and stay connected with Why Involve. Thank you.